The 63rd example, and what is said in this example: two small balls A and B, each of mass m, are joined rigidly to the end of a rod of length L. The system translates on a frictionless surface. With V naught in a direction perpendicular to dot. A particle P of mass m kept at the center. P of mass m kept at rest on the surface stick to A. So here there is particle P of mass m and it is kept here like this. As the ball collides with it, it sticks to it. So here the collision takes place. So I can say the linear momentum of A must be equal to linear momentum initial must be equal to final of the combined system. So m is mass V naught and this is 2m into the velocity of combined AP. So therefore the velocity of combined AP will be equal to V naught by 2. So this is velocity of point A after collision. While the B does not take part in the collision, so its velocity will remain V naught only. Now what is happening here? The system is going like this. This is answer to the first question. The velocity of center of mass. As the system, this is mass m going with V naught and this is mass 2m going with V naught by 2. This is by 2. So velocity of center of mass. So velocity of center of mass will be equal to m1 v1 plus m2 v2 upon m1 plus m2. This 2 get cancelled. So velocity of center of mass would be equal to. So mv0 plus mv0 will be equal to 2mv0 upon 3m. This mm get cancelled. So it will be 2v0 by 3. So center of mass is going with this velocity 2v0 by 3. In the third part, they said the angular speed of the system about c. So in order to find angular speed, we should have to consider the rotational motion of the rod. So here as the center of mass is going with velocity v0 by 3, this is going with v0 and this is going with v0 upon 2. So either we have to find the angular speed out of this, because this is net velocity of this point, this is net velocity of this point. In order to find the omega of the rod, we have to consider their rotational motion. So therefore the velocity of point B with respect to center of mass, because if we cancel the linear velocity from this, so I will get r omega here from this, because point B is having two velocities, v0 v plus r omega. So I will subtract v com velocity from this. So it will be velocity of point B minus velocity of center of mass. Velocity of point B is v0 and center of mass is v0 by 3. So this will go there. So it will be 2 v0 by 3. Similarly, velocity of A with respect to center of mass. So it will be velocity of A minus velocity of center of mass. So that would be v0 by 6. Now the distance of center of mass from B and distance center of mass from A, that we can find easily. Suppose distance from center of mass of A is how much? So it will be mass of B into total distance upon mass of A plus mass of B. So that comes out to be L by 3. Now we know that, so the velocity will be equal to r into omega, radius of A into omega A. So here this is v0 by 6 and this is L by 3 into omega. So therefore omega comes out to be v0 upon 2L, and that is the angular velocity of this rod. Thank you.